Virtual reality, or VR, creates immersive experiences that disconnect VR users from their physical environment. For example, the user here is currently in a confidential VR meeting with other people. Another person is standing nearby and records the user with his phone without the user's consent or knowledge. As a solution to this issue, the user can activate a pass-through view of the surroundings. However, this view creates a new dilemma, where the bystander is now being monitored through the headset's cameras and microphone. For example, here two people are having a conversation. Assuming the VR user can't hear them, the user is turning his head, which the other two notice, but it's not clear whether the head turning was part of the user's interaction in VR or had anything to do with the bystanders. We introduce Vice VRsa, a system for increasing awareness for both VR users and bystanders through visual cues in the physical as well as the virtual environment. Outside VR, we use color indicators that show the VR user's desired level of privacy. A public display shows details on the VR user's activities and details on what is being recorded about the surroundings and therefore the bystander. Inside VR, we use three representations to indicate a bystander's presence. A green halo shows the presence and rough location of a bystander. The radar view shows bystanders' locations in relation to the VR user in real time. And a live view, which shows a video of the surrounding area at the position a bystander is being detected. The VR user can set the desired level of privacy using 4 different modes. The modes are green, the least privacy sensitive one, yellow, orange, and with red being the most privacy sensitive. We illustrate Vice VRsa through an office scenario. Here the VR user is playing a game for a break during work. He wants to encourage others to join him in playing the game and therefore sets the privacy mode to the green level. In the green privacy mode, what the VR user sees inside his headset is live streamed to the display next to him. The color indicators light up in green. They are visible from a distance and even without a clear line of sight to the public display. Now a colleague walks by the user and notices the green lights at the distance and comes closer to watch the VR user's gameplay. After playing a game, the user joins a meeting with his co-workers. The meeting is not confidential and can be known to others, however the user doesn't want any bystanders to see what exactly he's doing or talking about, so he sets the privacy mode to the yellow mode. Inside VR, the yellow privacy mode is indicated. On the left, the user sees a green halo increase in size, indicating the distance and position of the bystander. Outside VR, the color indicators light up in yellow. On the public display, the upper half shows the name of the meeting and its duration, but not any live stream. In the lower half of the display, bystanders can see what features of the surroundings are currently being recorded. In this case, it is the presence and distance. After the casual chat, the user joins the business meeting. He doesn't mind if other people know about it, but he doesn't want bystanders to know about the meeting's contents and with whom it is. So he selects the orange privacy mode. In this mode, the radar view is enabled, marking the exact position of any bystanders in relation to the VR user. Outside VR, the color indicators change to orange. The public display shows a general notice about the type of activity the VR user is doing and again what is being recorded about the area. The bystander realizes that his location is being tracked and that the VR user doesn't reveal any details of the meeting, so he takes a few steps back. During the meeting, the user now realizes that the discussion is about to turn to the parameters of a new car's design. This is highly confidential, so he selects the red mode. In the red mode, he not only sees the presence and position of bystanders as indicated by halo and radar view, but he can also see who is around and what they are doing through a live camera feed in the VR environment. He can use this information to decide whether the bystander is authorized to overhear the confidential conversation. At the same time, outside VR, the bystander notices the color indicator switch to red, the public display shows a warning sign at the top, and at the bottom he sees the full video about him being recorded and shown inside VR. This makes him realize that the user needs complete privacy, so he walks away immediately. As shown in this scenario, Vice VRsa accommodates different desired levels of privacy as well as offering different levels of awareness for both VR users and bystanders about each other's presence. By leveraging color indicators and the public display in the physical environment and 3 presence indicators inside the virtual environment, which are halo, radar view, and live view, we explore how to support mutual awareness and increased privacy between VR users and bystanders in VR hybrid settings.